Good day, students. I want to recommend strongly that you read section 4.4. Go through the written out problems, every one of them, okay? I am going to do some examples of several types, but they have more examples, and so I recommend strongly that you go through them, and they have maybe a little slightly different approach, and that'll be okay. And we shall look at that as we go through this, okay? But definitely go through and do these problems, okay? So, and read them, okay? And study their examples as well. All right, here we go. I'm going to write some problems down and we're going to go from there. I'm going to refer to problems in your book, so you might want to have your book handy to look at those problems, and we'll go from there. Alrighty, here we go. Okay, here's the first problem. This is actually number 4 in your textbook, so you might want to look at that on page 324. It says the sum of 3 times the first number and twice a second number is 43. If the second number is subtracted from twice the first number, the result is -4. Find the numbers. Now, first thing I want you to notice is that you have 2 sentences here. There's the first sentence and there is the second one. They basically are both a number riddle that you have to write each equation using those number riddles, okay? So let's do that, all right? So it says the sum, so I'm going to add sum of what? 3 times the first number. So let me say x is first number. And let me say y is the second number. And then that'll keep them in order, all right? So 3 times the first number plus, or the sum with twice the second number, is 43. So there's one equation. Next equation. The second number, y, is subtracted from, so we subtract y from twice the first number, and that result is -4. Okay? So now we have 2 equations and 2 unknowns, and we need to solve the system. All right? Now, you can solve it any way you want. You can solve it by graphing. You can solve it by substitution. Or you can solve it by the addition method, whichever method you want. So I'm not adding things right away here. So I will probably do substitution. So I'm going to subtract 2x from both sides, and I get -y equals -4 minus 2x. And then I divide everything by -1, and I get y equals 4 plus 2x. So I then substitute that into the first equation. So 3x plus 2 times 4 plus 2x equals 43. So 3x plus 8 plus 4x equals 43. That's 7x plus 8 equals 43. So 7x is equal to 35. I subtracted 8 from both sides. And so x is equal to 5 when I divide both by 7. Okay? So now I know what x is. And since I know what x is, I can then... So that's one of the numbers. And then the next number, I can do 2 times 5 minus y equals negative 4. So that's 10 minus y equals negative 4. So I subtract 10 from both sides. Get negative y equals negative 14. Divide by negative 1. And get y equals 14. So there's my two numbers. All right? And that's pretty much it. I can then check it. Is 3 times 5, 15, plus 2 times 14, 28. 15 plus 28 is 43. So that checks. So I feel pretty good about it. Now, I could have used graphing to get this. Graphing, if you get fractions, is not going to be nice. But this one, it would work just fine. Okay. In fact, I would graph them to check to make sure these are the correct answers for the equations you wrote. All right? But that's the problem method. You're trying to set up some equations, and then you can use any of your methods. Graphing, substitution, or the addition method. And I'll do different methods throughout just to review those. Okay? Let's try another problem. So, whoops. Okay, here's our next problem. This happens to be number 8 on page 324 in your textbook. And it is 1 Snickers bar and 2 Reese's cups contain 737 calories. 2 Snickers and 1 Reese's contain 778 calories. Find the calorie content of each bar. Okay, so look at that. So the first thing we need to do is set up the equations. Now, one of the things I like to do is I like to set up like a little box. And these boxes have 3 pieces. And what I know is one situation they tell me has 737 calories, and the other one has 778. So I know this will be the number of Snickers, and this could be the number of Reese's. All right, and then this is the first situation, and this is the second one. In the first situation, I have 2 Snickers bar and 1 Reese's. In the second, I have 1 Snickers. Whoops, I did that backwards. Oh my gosh. In the first situation, I have 1 Snickers and 2 Reese's. In the second situation, I have 2 Snickers and 1 Reese's. How do I then create equations out of this? Well, if we let my variables be S for Snickers and R for Reese's, gosh, that seems strange, right? Then I can say I have 1 Snickers bar plus 2 Reese's bars equals 737. And I could say 2 Snickers bars plus 1 Reese's bar equals 778. Now, let me clarify on my variables. This is the calories of a Snickers bar, and this is the calories of a Reese's. So 1 bar times whatever the calories of the Snickers are, plus 2 Reese's times whatever the calories of the Reese's are. So we're adding calories to get 737. And the same thing on the next equation. So I'm pretty confident these equations are correct. So I just need to move forward. Now, when I have big numbers like this, I generally don't graph because the graphs could be hard to find on the graph paper. So I'll probably just do the addition method here because it'll be pretty easy multiplication. I'm going to multiply this first equation by -2. So I get negative 2s minus 4r equals a negative, and I just double that. So 14.7 and 1474, negative 1474. So now I can add these two equations together. 2s minus 2s is 0. 1r minus 4r is negative 3r equals, and then 1474 minus 778 would be a negative number. This is a great calculator thing. I don't have a calculator handy, so I got to do it in my head. 14 minus 8 is 6, and then 16 minus 7 is 9, and then 13 minus 7 is 6. So 696, and let me add that to 714. 9 and carry the 1. Just add these together. 17, carry the 1, 14. Okay, so that's correct. And now I divide both sides by negative 3. So I get r equals 2, 3, 2. So the number of calories in a Reese's, the number of calories in a Reese's is 232, and then the number of calories in a Snickers is, and I don't know that yet, I got to figure it out. So I need to substitute the 232 in one of my equations. So I'll do 2s plus 1 times 232, or 232 equals 778. So I'll subtract 232 from both sides. And I get 2 times Snickers calories equals 645. And I divide both by 2, so Snickers has 273 calories. And so I can put 273, and there's my solution. All right, any questions? Sort of seeing how it helps. You see how the box just kind of helps you organize how to put things together. I've always enjoyed that as a technique. All right, let's try another one. And there are quite a few. They all seem a little different, but they're all very similar, and the box can make them similar, and I'll show you that. Here we go, next problem. Okay, next problem. This is number 16. There are some problems between 8 and 16 that use kind of a slope percentage. I'm going to let you read those. Those are fairly standard, how you would set those up. You're using the slope-intercept form. I'll let you take a peek of that on your own. Can't show you every problem here, as I don't want to make the video too long. But I want to move on to some of the other options. So in this one, you have the perimeter of a tennis court is 228 feet. After a round of tennis, a coach estimates that an athlete ran a distance of 690 feet, which is equivalent to 7 times the court's length plus 4 times its width. And they want to know, what are the dimensions of the standard court? Okay? So there's the problem. We need to set it up. And so they did perimeter. And so what I know is perimeter equals twice the length plus twice the width. And I also know that the perimeter, erase, is 228 feet. So that's one equation. Now the next equation, they said, and let me pause on this for a minute. Sometimes I get ahead of myself. Let me go back to the box. All right. And there are 3 components. So we know we have 228 feet and 690 feet. And so it's got to be some kind of length and some kind of width, right? And so we know it's twice the length and twice the width that we add together to get 228. Well, in this next one, the 690 feet, they say it's 7 times the length. And then they say it's 4 times the width. And so when I look at this, I can very quickly write the equations just by organizing my data into a chart, and that makes it really nice. So there we go. There's that. I do want to show you, I'm sure by this point some of you are going to love graphing as a solution method. And so I want to show you what happens with big numbers. So I'm going to solve this one by graphing. All right? Because I think it's worth it to look at that. So twice the length, so we'll go 2x plus 2y, 2y equals 228. Okay, now you see how that disappeared off the screen as that number got bigger. And then 7x plus 4y equals 690. Now, notice that these things are kind of off the screen. And if I look at 2x plus 2y, suppose x takes up everything. It looks like x has got to be could be a maximum of 50, 60 feet. All right, just think of a tennis court. And maybe the length is, and in this case, the x is length and the width is the w is y. So keep that in mind because we wrote x and y. So now, if I'm going to do this on graphing, what I got to do is change the scale. So you can do that by hitting this little tool here. And you can say, oh, well, let my x-axis, I'm going to, tennis court lengths aren't less than 0. And maybe they'll go up to about 100 feet. So I'll do that for x, for the length. And the width won't be less than 0, but it might go up to about 50 feet. So I'll do that. And so I'm kind of thinking realistic here to give me an idea of what happens. And once I do that, I can hit the toolbar, and there are the graphs. I can see the graphs now. And so then I can click on this point here, and it says it's 7836. So I use graphing to solve this, a graphing calculator, and so I got 78 and 36. So the length is equal to 78 feet, and the width is equal to 36 feet. Okay, now I want to check that. Okay, so I'm going to go twice the length, which will be 156 feet, plus twice the width, which is 72 feet, and I want to see if that's equal to 228. And what I get is 8, 7 plus 5 is 12, carry the 1. So it is 228 feet. So I feel like, because you could click on this, you could click on points anywhere on this graph and get the wrong ones. Now, generally, when you click here, they know you're trying to get the point in the middle. So you're going to have to, if you use graphing to solve one of these, you want to check. And then, but notice, sometimes you have to look for a graph. And so you want to keep that in mind. It may not show up on your screen. All right? So, but I wanted to show you one where you solve it by graphing. Now, you could do this by the addition method or by substitution. It would work out really well. Okay, let's go on to another problem. So now that I have showed you how to solve these, and that you can do it really by any method, I'm going to focus on setting up equations. So setting them up, just so we can see a few more in the video where we can see a few more ways to set things up. So the first one I'm going to focus on is number 22. And it says you are choosing between two plans at a discount warehouse. Plan A offers an annual membership fee of $300, and you pay 70% of the manufacturer's list price. Plan B offers an annual membership fee of $40, and you pay 90% of the manufacturer's list price. How many dollars of merchandise would you have to purchase to pay the same amount under both plans? And then they ask what will be the cost for each plan. All right, so let's take a look at that. So what we do is we got to figure out the variables. And so the variables in this one are the percent of manufacturer's plan. So that's one variable. So I'm going to call it X. What's the other variable? Y is the amount when plans are equal. All right, the total, or you could say the total amount spent on a plan. Okay, either way, you could think of it that way. So notice the first plan, you spend $300 and then you pay 70% of the plan's cost of the price of the items, and then that will equal the total amount. The other one, you spend $40, but then you pay 90% of the plan's amount, and then Y, you're going to spend up to Y. Now notice the plans are equal. This is a perfect one for substitution since they're each solved for Y. All you have to do is set these equal to begin to solve it. And then you're on your way to a solution. Now, you may want to check this, and just so you know, X will be $1,300. Let me see. Let me look at this again. Let me pause. Yeah, let me clarify the variables. X is you pay 70% of, not the percentage of the main plan, but it's the percent of the main plan's merchandise. It's how much merchandise you buy. So when you do this problem, when you solve it, X is going to be $1,300. You got to spend $1,300 for these to equal. And then Y will be $1,210. That'll be the amount you spend overall. Okay? Anyway, that's all I have for you on that one. Let's go to another one. So the next problem is an interest problem. What we're going to do is we're going to invest $20,000 in two accounts. One earns 7% interest, one earns 8% interest. And what we're going to know, certain things, we're going to know that at the end of the time, we're going to earn $1,520. And so we're going to use our box method on this. And let's talk about it and how it works here. So one of the things I know is I don't know how much I put in the 7% account. I could just say I put X in there. And I don't know how much I put in the 8% account, so I could just put Y. And typically when you invest, you don't know how much you're going to make every year anyway. So you don't know if you're going to get 7% or 8%. I mean, why wouldn't you put it all in the 8? So this is all revealed at the end of the year. And that's the point I want to make. So the first thing you know is you do have a couple of totals in the problem. One of the totals is $20,000. It's how much did you invest? Well, you invested X plus Y, and that would equal $20,000. You had a total amount of $20,000 you put in these two accounts. And then you had another total. You earned $1,520 in interest. So this means you need to be able to write these formulas in terms of interest. Well, what's interest going to be? Well, interest is principal times the rate for a year. So X times 7% is the interest you earned on the amount of money that you put in that account. So we would write 0.07x, and for the y one, 0.08y, and we would add those together, and that'd be the 1520. Well, there are your two equations. X plus y equals 20,000, and 0.07x plus 0.08y equals $1,520. This is the total money, and this is the interest money earned. So really two equations with two unknowns, same unknowns, and you have to know how to put them together. Now, in this case, you could graph them, use substitution. I'd probably do y equals 20,000 minus x and plug that in there, and then I'd solve. Okay? All right, so there's an example. If you want to solve it, you should get $8,000 for one account and $12,000 for the other. All right? Sorry about the cough. Let's go to the next problem. The last type of problem I want to do is called a mixture problem. And it's very much like the interest problems. We're going to use the box just to help us organize our thoughts. All right? And we're going to look at problem number 41. Now, in that problem, it says how many ounces of a 15% alcohol solution must be mixed with 4 ounces of a 20% alcohol solution to make a 17% alcohol solution. Okay? Now, what are the unknowns? Well, X, we don't know how much of the 15%. And Y, we don't know how much of the total. So when you look at this, the first equation comes from just the mixture amounts. You take X amount plus 4 ounces, and you should get Y amount. So this is what I call the ounce equation. And then the next one is the percent equation. And it works very much like it did on the last problem. We have 15% of the X is alcohol. And we're going to mix it with 20% of the 4 ounces, also alcohol. And we're going to end up with 17% of the total amount. And so there's your two equations. X plus 4 equals Y, and 0.15x plus 0.20 times 4 equals 0.17y. And this is very typically, we did this in chemistry a lot when I took chemistry. So there you go. Mixture problem. Okay? This is very typical. This is how they set up in a standard way over and over. Alrighty, that's all I have for you today. We'll talk to you later. Bye.